Here's problem 2 from homework number 8. We have a student is attempting to loosen a pipe attached to a bracket in the U-Hart machine shop. The dimensions are XO is and XB, XOB, XAB, and XAO and XBO are both 16 inches. The dimension here is 10 inches ZAB, and then there's 20 inches ZBO. Determine the required FA and FB to create a torque of 35 inch-pounds. This is a really easy problem. I didn't mean to don't make me to feel bad if you struggled with it, but this is a pretty easy problem. But we'll go through it. There's probably going to be some people that go, wait a minute, that seemed too easy. Well, you know, didn't mean to make it, every problem needs to be incredibly difficult. Alright, I'll draw this quasi-looking thing here. Here's my, I do have the templates to make asymmetric circles. And I could do it, but I chose not to. Let's see, we put a wrench on there. I'm going to draw the wrench freehand here. It doesn't need to be pretty, but I'll make it, try to make it look pretty accurate. Right there. Just make it look like a wrench. Maybe even give it a little bit of right there. Okay, and then this one right here, he's poking his head up. And I guess we'll make him look a little bit like a wrench. There you go. All right, and we have a force coming down on it, FA, and then we have a force coming up on it right here, FB, so that is obviously B, and this is obviously A, and we gave a bunch of distances. Spoiler alert, not all the dimensions are needed. So that's XAO. I guess this is O. And this is a tough one to get in there without making it look messy. So I'm going to stick him over here. Say that this is going to be XBO. That's the X direction. It's the Y direction. It's the Z direction right there. Here on there, I'll just put them right there. Put little arrowheads. I should do a better job of drawing my arrowheads, but let's get these leaders tame those leaders down. That's not as parallel to that as it should be here. All right, let's not be too picky. AB. Z, was that BO? Alright, so given. I guess this doesn't need to be this long. I could make the video shorter if I didn't write these out while recording, huh? But I want to encourage you to be doing this. I don't know if that's a useful thing or it will happen because I'm making the videos with me working the things out, but I kind of wish it would help. All right, so we want to find FA and FB that equals 35 inch-pounds to create 35 inch-pounds. That's my way of shorthand of writing the thing right there. You get the idea, right? And maybe say that it's a couple, right? This is like almost too easy. We could make it more complicated. We don't have to, right? It'd just be when a couple. We could say that it's about O if we want to, but once it's a couple, it doesn't matter because these are going to be equal and opposite, right? In fact, the problem didn't even say determine the forces required to create a torque here. They could be different forces, right? This could be 0, and that could be whatever this would need to be, right? So I didn't say that they were going to be equal to each other, but maybe it was implied in there. All you need to do is say FA times this distance right here. So this is 16 inches, and this is 16 inches, right? That's right there. So just take it times 32 and make it equal to 35 inch-pounds right there. So all you have to do is say FA is going to be equal to FB and going to be equal to 35 divided by 32. I should have picked another thing. It'd be 1.094 pounds. I don't know why I picked these numbers. I could have picked better numbers than this, but that's what would do it. That's simple, right? It's like way too simple. But what we could do is we could just say, we didn't say that it had to be a couple, but oh well. I feel kind of silly for having made a problem that was that easy. I didn't look at the solution to the thing. I just looked at the problem. I said, "Oh, that sounds like a pretty good problem." But they don't all have to be incredibly difficult. So it took me most of this time. It took me just drawing this thing out, right? 7 minutes.